Hey everyone, our research project is predicting the likelihood of cardiovascular disease based on pre-existing health conditions and lifestyle choices. And it's by me, Aalaap, Ethan, Riya, Anishka, and Rushil. Yeah. So cardiovascular disease is actually the world's leading cause of death, and it comes in many forms. It can come from either a heart attack or stroke. Around 18 million people suffer through heart disease each year. And how does heart disease form? It forms from diseased vessels, blood clots, and other heart-related structural problems. So we had a huge data set that we wanted to utilize, and we figured the best way to predict our end outcome was using a random forest classifier, which allowed us to create multiple unique decision trees to accurately predict the likelihood of someone getting cardiovascular disease.
So first, before even creating our data model, we needed to find a good data set to maximize the accuracy of our data model. The two requirements for a good data set is that it had a large number of entries/inputs from our patients. And the second is that it had to have a good amount of features, which include age, weight, blood pressure. We found the perfect data set on Kaggle, which included 70,000 inputs from our patients, and it had 11 different data set features. With this, we took our data set and moved on to data interpretation.
You guys okay there?
I think Ethan's talking, but we can't hear him. So,
do you have someone who could fill in for him? Just go ahead and jump on in if you do. Yeah, if they're talking, we definitely can't hear it. Who in the group would be able to talk about this part?
Okay, so for our data, he said he's trying to fix it.
Yeah, you could definitely try, but we got to keep things moving because we have such a short period of time. I know we have technical difficulties from time to time. It's understandable. Is there anyone else who could talk about it?
I can continue. So for the next step of our process, we performed EDA, which stands for exploratory data analysis, on our data set. So what this means is we built different graphs such as histograms, box plots, heat maps to understand our data. So on the right is a heat map, which shows the correlation between different features. And as the color changes and it gets closer to red or blue, it shows a more stronger negative or positive correlation.
Okay. Can you hear me?
Yes.
Okay. Okay, so we also built histograms for each column to see how the data was distributed. For example, on the histogram on the left, which shows the glucose levels of the patients in the data set, with 1 signifying normal glucose level, 2 signifying above normal glucose level, and 3 being well above glucose level, we can see from this that around 60,000 patients in our data set had normal glucose levels, and out of these patients, around 28,000 had heart disease, which is signified by the cardio value. And we also did this for all of the columns to help us understand what variables had the biggest impact on heart disease. Furthermore, on the histogram on the right, which shows how the weights of patients in the data set are distributed, we see that the weights are slightly skewed to the right, and the most occurring weight was around 66.5 kilograms, with around 20,000 patients having around this weight.
Okay, so how did we build the model? So we used a random forest classifier as our model. And the first step we did was split our data into a training set and a test set. So we used the training set to train the model, and then we used the test set to basically test the model. So the training set needs to be large enough and representative of the whole data in order to get accurate results. So we put 80% of our data into the training set to train it. And the libraries that we used to do this on Python were pandas, sklearn, and we used matplotlib to graph the data beforehand. So basically how the model works is you use the samples from the data set, and it goes into a decision tree for each sample. Then each tree goes through voting. And finally, after the voting, the most voted prediction is the final result that we receive. And in our code here, we have the different features of the patients. We have their age, their gender, their height and weight, their systolic and diastolic blood pressure, their glucose intake, their cholesterol intake, whether they smoke or not, whether they are physically active or not, and their alcohol intake. We also did a confusion matrix, which will be shown in the next couple slides.
So in order to improve our model's performance, we did hyperparameter tuning and tuned some of the parameters of our random forest classifier, such as the number of trees and the depth of the trees. And we found an optimal value for these parameters through a graph called an AUC curve. So on this slide is one of the graphs which shows how different values for the tree depth parameter affects the model's performance. So as you can see through the red curve, which represents a test set, having a tree depth of around 13 seems to result in the highest score accuracy. The next thing we did for our improvements is feature selection. So with our feature selection, we removed some of the features that were not as important or relevant to our model, and we chose which features to remove based on calculating the feature importance, which I'll be talking about in the next slide.
You guys have just about 2 minutes.
Okay. For our model's accuracy, we got 81.83% on our train set and 73.08% on our test set. And we created a confusion matrix to show the number of values that model classified correctly versus incorrectly. And on our slide is the confusion matrix for the test set. The green squares show the number of true positive and true negative values, and the red squares show the number of false negative and false positive values. And then we also calculated the feature importance, which shows us the scores or the importance of each feature and how much it affects the model. So from this, we can conclude that age, weight, systolic blood pressure, and height are the biggest risk factors or features that affect cardiovascular diseases the most.
We would also like to thank ASDRP for providing us with this research opportunity, and our mentor, Mr. Subramaniam, for guiding us through this research project and providing us with feedback and our advice.
Thank you for listening to our presentation.
Welcome, nice job. Any questions? We can do a couple. Make sure we have an opportunity. I'll ask one. Do you plan on continuing this study throughout the fall semester?
I think for the future, we're not exactly sure if we're going to continue working on the model, but if we were to continue, it'd be in the form of a larger research paper, so we can just share these findings with a larger audience.
Gotcha. Okay.